Bismillahirrahmanirrahim. Today we are going to discuss a worldwide environmental problem called acid rain with reference to environmental chemistry. Here we discuss the major sources and mechanism of acid rain, about its control and its effect on building and vegetation. Acid rain is caused by a chemical reaction that begins when compounds like sulfur dioxide and oxides of nitrogen are released into the air. These substances can rise very high into the atmosphere where they mix and react with water, oxygen and other chemicals to form more acidic pollutants known as acid rain. Normal rain has a pH value between 5 to 5.5, which is slightly acidic. However, when rain combines with sulfur dioxide or nitrogen oxides, the rain becomes much more acidic. Typical acid rain has a pH value of 4. There are two types of acid rain. Number one is the wet deposition and number two is the dry deposition. Wet deposition refers to acidic rain, fog and snow. As this acidic water flows over and through the ground, it affects a variety of plants and animals. On the other hand, dry deposition refers to acidic gases and particles. About half of the acidity in the atmosphere falls back to earth through dry deposition. The term acid rain was coined in 1852 by Scottish chemist Robert Angus Smith. Royal Society of Chemistry called him father of acid rain. He wrote about his finding in 1872 in the book Air and Rain, The Beginnings of a Chemical Climatology. In the 1960s and early 1970s, acid rain became recognized as a regional environmental issue. Now let's see the causes of acid rain. Rotting vegetation and erupting volcanoes release some chemicals that can cause acid rain. The biggest sources are coal burning power plants, factories, oil refineries and automobiles. Sulfur dioxide and nitrogen oxides are released into the atmosphere. These air pollutants react with water, oxygen and other substances to form sulfuric acid and nitric acid that mix with precipitation and fall to the ground. The reaction takes place in the following manner. Number 1. Sulfur dioxide reacts with water to form sulfurous acid. Number 2. Sulfur dioxide reacts with ozone to form sulfur trioxide and oxygen. Sulfur trioxide in turn reacts with water to form sulfuric acid. Mononitrogen oxide reacts with oxygen to form NO2. NO2, which in turn reacts with water to form nitric acid and nitrous acid. The sulfuric acid and nitric acid remain in vapor state. At higher temperature, the condensation begins at low temperature together with rain, fog and snow, which increases its acidity. This picture presents the previous discussion efficiently. It shows well-established chemical reactions which have already discussed in the previous slide and the difference between dry deposition and wet deposition. Now let's look at the major contributors in acid rain. Natural process contributes 10% sulfuric acid. Industrial combustion 69.4% sulfuric acid. Vehicular transportation 3.7% sulfuric acid. Natural processes like lightning, volcanic eruption, forest fire, action of bacteria contributes 5% oxides of nitrogen. Industrial process 32% oxides of nitrogen. Vehicular transportation 43% oxides of nitrogen. According to the Environmental Protection Agency, 2/3 of the sulfur dioxide and 1/4 of the nitrogen oxide found in the atmosphere come from electric power generators. This picture represents the previous discussion efficiently, that from where oxides of nitrogen and sulfur escaped into the atmosphere and how they form dry and wet deposition. Now let's have a look at the effects of acid rain. Acid rain has a serious implication for continuation of life on this planet. The main acid rain problems are number one, effects on water bodies. Rivers and lakes have a pH range between 6 and 8. Acid rain in these water bodies altered the chemical environment, which may be a threat for the survival of flora and fauna. Soil with poor buffering capacity may release aluminium ion, which is toxic for the aquatic life. Effects on soil and forest. Acid rain is being cited as one of the major causes of degradation of a forest at higher altitude of the Appalachian Mountains from Maine to Georgia. Forests are affected directly as well as indirectly by the acid rain. Acid rain changed soil acidity. In its bid to neutralize, soil releases substances that are toxic for trees growing on it. Acidic water also dissolves nutrients in the soil before they can be absorbed by flora growing on the forest floor. Now, the effect on aquatic flora and fauna. Acid rain can directly affect on aquatic lives as the high amount of sulfuric acid and nitric acid level in the acid rain are directly consumed by the aquatic animals and plants. The harmful acid affects the ability of a fish to take in nutrients, salt, and oxygen. Many bacteria and blue-green algae are killed due to the acidification, this disturbing the entire ecological balance. Acidic water can also leach aluminium from the soil. This runoff carries dissolved aluminium to lakes, rivers, and streams, cause death of the fish by clogging its gills and deprives it of oxygen. Acid rains affect the pH level of the water, which reduces the absorption capacity of essential nutrients of the aquatic life. This also hampers the reproduction process of the fish, leading to weak or brittle eggs. Now, the effects on human beings. Acidification affects human nervous system, respiratory system, digestive system. Acid contaminates with potable water and enters man's body. The heavy metal released by the acid rain may cause potential threat to human health. Effects on terrestrial ecosystem. Demineralization of soil occurs. Cations like calcium, sodium, potassium, and magnesium are leached away and replaced by acidic cations such as aluminium. Nitrogen fixation ability of nitrifying bacteria diminishes rapidly below pH 6. Acidification of soil adversely affects soil fauna and leads to reduced forest productivity. Acid rain has retarded the growth of vegetables such as pea, beans, radish, spinach, and carrot, etc. Continuous chronic exposure to low levels of acidic water causes diffuse chlorosis in plants' leaves. Now, the effect of acid rain on building material. Acid rain causes extensive damage to building and structural material of marble, limestone, and salt, etc. The attack of acid in marble is termed as stone leprosy. Marble, which is a calcium carbonate CaCO3, reacts with sulfuric acid to form calcium sulfate, water, and carbon dioxide. Acid rain corrodes houses, monuments, statues, bridges, fences, and railing that require huge cost for maintenance every year. Acid precipitation causes damage to steel, oil-based paints, and automobiles coating. It disintegrates textile and paper also. In the United States, the Clean Air Act of 1990 targeted acid rain, putting in place pollution limits that helped cut sulfur dioxide emission 88% between 1990 and 2017. Air quality standards have also driven US emission of nitrogen dioxide down 50% in the same period. Now let's see the number of possible solutions for acid rains. One of the most fundamental acid rain solution is to utilize fuel that burn more clearly or more efficiently. The best solution for the industrial power plants is to attach devices known as scrubbers in the chimneys. These scrubbers reduce the amount of sulfur produced in the smoke by 90 to 95%. Vehicles and cars must be required to comply with very tight and efficient emission standards. Fitting catalytic converter into the exhaust pipe also reduces the amount of sulfur dioxide produced by the vehicle.
What is acid rain? Acid rain is any form of precipitation with high levels of nitric and sulfuric acids. It can occur in the form of snow, fog, and even dry materials that settle to Earth. Most acid rain is caused by human activities. When people burn fossil fuels, sulfur dioxide and nitrogen oxides are released into the atmosphere. These gases react with water, oxygen, and other substances to form sulfuric and nitric acid. Winds may spread these acidic solutions over hundreds of miles. After it falls to Earth, acid rain enters water systems as runoff and sinks into the ground. This can make water toxic to crayfish, clams, fish, and other aquatic animals. The rest of the food chain, including non-aquatic species such as birds, is often affected as well. Acid rain also harms forests by damaging trees' leaves, robbing the soil of essential nutrients, and making it hard for trees to take up water. By designing cleaner power plants and using fewer fossil fuels, we can reduce the number of pollutants that create acid rain.